Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved the last question of exercise number 4.2 with which chapter number 4 has been completed. Chapter number 4 was actually the differentiation of vector functions. In today's video, I am going to solve the next chapter, chapter number 5. Integration is the name of this chapter. The other name of this chapter is also an antidifferentiation, because this process will be actually totally goes to differentiation. That's why the other name of this chapter is antidifferentiation. So in today's video, I am going to solve the first exercise, the first question of exercise number 5.1 related with the indefinite integral that we will solve in this video. So let's move toward chapter number 5, integration, class FSC part 2 mathematics, exercise number 5.1. Question number 1 tells that evaluate the following indefinite integral and check the result through the differentiation. So the first part is integral of x power 4 plus 3x power 3 minus 7 into dx. So move to the solution of part number first. This x power 4, 3x power 3 minus 7, this dx is multiplied with each and every term. So we can write it x power 4 dx. And after this plus 3, this 3 is a constant, so we will write it outside of the integral. So 3 into x power 3 dx. And after this minus 7 is a constant, so we will write it outside of the integral, and inside we can write 1 dx. So because minus 7 into 1 gives us minus 7 dx, and 3x power 3 dx and x power 4 dx. Now remember that the general formula of integration, that integral of x power n is also always equal to x power n plus 1 divided by n plus 1 plus constant of integration. So we will use this formula over here. We will just add 1 in the power and also in the division or in the denominator. So over here, using the formula add 1 in the power, so it become 4 plus 1, and using the same rule in the division, it become 4 plus 1. Now over here, plus 3 will come down as it is, and x power we have 3, so add 1 and also add 1 in the denominator, and over here minus 7. Remember that the integral of 1 is always equal to x. So why? Because if we differentiate x with respect to x, it will give us again 1. That's why its integration will be x, and we will write plus constant of integration c. Now after this, it become x power 4 plus 1 will give us 5 divided by 4 plus 1 gives us 5, and over here it become plus 3, x power 3 plus 1 gives us 4, and divided by 3 plus 1 gives us 4, and over here minus 7x will come down as it is, and plus constant of integration will come down as it is. So this is actually the required answer. Now after this, they tells that and check the result to the differentiation. So over here we will check that either our result is correct or wrong. So we will use the differentiation. So x power 5 integration, you know that it is 5x power 4, because this power will come to the front and we will subtract 1 in the power, it become 5x power 4. And this power 5 is a constant, it will come down as it is. After this 3 will come down as it is, the power will come to the front and we will subtract 1 in the power, so 4 minus 1 gives us 3. And divided by this 4 will come down as it is, and minus 7 will come down as it is. X is actually derivative is 1, so dx by dx gives us 1, so it become minus 7, and constant derivative is 0. 5 can start with 5, we left with x power 4, and 4 can start with 4, we left with 3x power 3, and minus 7 will come down as it is. Now look at the given. Over here we have given with x power 4 plus 3x power 3 minus 7, and over here we also have x power 4 plus 3x power 3 minus 7. It means that our required result x power 5 by 5 plus 3x power 4 over 4 minus 7x plus constant of integration, this is actually the correct answer. Now move to the second part of question number 1, part number B. It tells that integral of 1 over x power 3 dx. So move to the solution of this part number B. Remember over here the power of x is positive, so by moving to the numerator, their power will become negative. It become x power negative 3 dx. We will use this formula that a power negative m is equal to 1 over a power m. So over here a is x and m is 3, so it will be equal to a power negative m. A is x and m is 3, so it become x power minus 3 dx. Now we will use the general formula that x power n integral is x power n plus 1 divided by n plus 1 and plus constant of integration. Using this formula over here, it become x power minus 3 will come down as it is, just 1 add in the power, and also add 1 in the denominator with negative 3, so it become minus 3 plus 1 and plus constant of integration. So it become x power minus 3 plus 1 will give us minus 2, and divided by minus 3 plus 1 will give us minus 2 and plus constant of integration. So this is actually the required answer. Now they tell us that check the result through differentiation. So differentiate this function. Now we checking that either our answer is right or wrong, so just differentiate. So x power negative 2 differentiation will be the power will comes to the front, and subtract 1 in the power, so it become minus 2 minus 1 will give us minus 3, and this minus 2 will comes down as it is, and constant derivative is 0. So they cancel with each other. We left with x power minus 3, which can be written as 1 divided by x power 3, which is actually our required, which is actually our given. So it means that our required answer is correct. Now move to the next part, or part number C. It tells that integral of 2x power 4 plus x power negative 2 by 3 minus x power negative 5 by 3 dx will be. So we can write our given integral in the split form. So we can write it just like integral of 2x power 4 multiply dx. It becomes 2x power 4 dx. Now after this plus x power integral of x power negative 2 by 3 into dx, and apply the integral on this term, so it becomes integral of negative x power negative 5 by 3 dx. Now after this 2 is a constant, so take it outside of the integral, it becomes x power 4 dx, and over here it comes out as it is x power negative 2 by 3 dx, and over here minus is a constant, so it comes down, it will comes out from the integral, it becomes minus time of x power minus 5 by 3 dx. Now using the general formula, so integral of x power 4 will be according to the property add 1 in the power, so 4 plus 1, and also in the division 4 plus 1. Now after this over here add 1 in the power, so it become minus 2 by 3 plus 1, and also in the division minus 2 by 3 plus 1. And apply the same logic over here, minus time of x power minus 5 by 3 add 1 in the power, and also in the division. So after this it become 2 into x power 4 plus 1 gives us 5 divided by 4 plus 1 gives us 5, and over here minus 2 by 3, 1 can be written as 3 by 3, so 3 minus 2 gives us 1 by 3, so it become x power 1 by 3, and over here minus 2 by 3 plus 1 gives us 1 by 3, and over here minus into 1 can be written as 3 by 3, 3 divided by 3, because it again gives us 1, and over here also 1 can be written as 3 by 3. So 3 minus 5 gives us minus 2 by 3, so it becomes x power minus 2 by 3, and divided by it gives us minus 2 by 3. Now after this 2 by 5 x power 5 will come down as it is, and this one 3 will move to the numerator because this is in third division, it becomes 3 into x power 1 by 3, and minus minus gives us plus, this 3 will move to the numerator, and this 2 will come down in the denominator, and x power negative 2 by 3, it will move to the denominator, it become positive, so it become x power 2 by 3. So this is actually the required and desired answer. Now if you differentiate this function, it will give us 2x power 4 plus x power negative 2 by 3 minus x power negative 5 by 3. Now move to the next part, or part number D. It has that integral of 1 plus 3t multiply t cube dt. So move to the solution over here. Over here we have 1, so 1 multiply t cube dt, it will come down t cube dt integral, and after this plus 3t into t cube, so it become 3t into t cube dt, 3t multiply t cube into dt, and 1 into t cube dt. Now after this integral of t cube dt, over here 3 is a constant, so it will comes down from in outside of the integral, t multiply t cube, it will give us our t power 4 dt. Now using the generalized power rule of integration, add 1 in the power, it becomes 3 power t power 3 plus 1, and add the same logic in the denominator. So after this plus 3 will come down as it is, t power 4 will be just add 1 in the power and also in the denominator, and plus constant. It becomes t power 4 divided by 4, and it becomes 3t power 5 divided by 5 plus constant. So this is actually the required answer. Now they tells that check the result of differentiation. So if we differentiate, it becomes 4t power 3 divided by 4, and it becomes plus 3 into 5 t power 4 over 5, and constant derivative is 0. So they cancel out with it, so it becomes t power 3, 5 cancel out with 5, we left with 3t power 4. So over here we have t cube plus 3t power 4, so it means that the required answer is correct. Now move to the next part, or part number E. It tells that integral of t square minus 1 whole square dt will be. First we will use the formula that you know that a minus b whole square, a minus b whole square, this is always equal to a square plus b square minus 2ab. So let's suppose here a is t square and our b is 1. So putting over here a t square, so it becomes t square, and b is 1, so it becomes minus 1 whole square. So a is t square, so it becomes t square whole square plus b square, b is 1. So 1 square minus 2 into a is t square, and b is 1. So t square minus 1 whole square will be t power 4 plus 1 and minus 2 t square. So putting the values over here, move to the solution. It become integral of t square minus 1 whole square is t power 4 minus 2t square plus 1 into dt. Now it can be written in the split form t power 4 dt and apply the integral sign, and it become minus 2 is a constant, so we can write it t square dt, and 1 can be written as inside the integral 1 dt. So it become t power 5 divided by 5 if we apply the generalized power rule. Add 1, so it become t power 5 and using the same rule in the division, and it become minus 2 into t power 2 plus 1 gives us 3, and also write 3 in the division, and plus 1 derivative integration, you know that it is t, because if we differentiate t it gives us 1. So integration of 1 is t and plus a constant of integration. So this is actually the required and desired answer. Now by differentiation it will give us t power 4 minus 2t square plus 1. So it means this is the required answer. Now move to the next part of part number f. It tells that integral of x power 3 plus 1 whole divided by x power 3 dx will be. Move to the solution. It can be written as x power 3 divided by x power 3 into dx and plus 1 divided by x power 3 into dx. So they can start with each other. We left with 1 dx and over here x power 3. So move to the numerator, it become x power negative 3. Now integral of 1, you know that it is x. So because if we differentiate x with respect to x, it gives us 1. And x power negative 3 integration will be, we will just add 1 in the power according to the generalized power rule, and using the same rule in the division minus 3 and add 1. So it become x will comes down as it is. X power minus 3 plus 1 gives us minus 2 and minus 3 plus 1 gives us minus 2. So x will come down as it is. Plus and minus 2 can be written as minus 1 by 2. X power negative 2 move to the denominator, it become power will be positive, it become x power 2 plus c. So this is the required result. Now if we differentiate this, it will give us the required x power 3 plus 1 divided by x power 3. It means this is the required result. Move to the last part of today's lecture and the last part of question number 1, part number G. Integral of z square into under root of z into dz. So z square will come down as it is. Z under root can be written as z power 1 by 2 dz. Now the bases are same, which is 0. So the power will be added, which is 2 and 1 by 2. So 2 plus 1 by 2, it will give us 5 by 2. Now using the generalized power rule, add 1 in the power, and using the same rule in the denominator, it becomes 5 by 2 plus 1. So 5 by 2 plus 1 will give us z power 7 by 2, and 5 by 2 plus 1 in the division will give us 7 by 2. Now this 2 is in the third division, it will move to the numerator, it become 2, and this 7 will comes down as it is in the denominator, and z power 7 by 2 will comes down as it is, and plus constant of integration. So this is actually the required result. Now if you differentiate this function, it will give us the given z square into under root of 0. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics Integration Chapter number 5. Thank you.